Hi everybody. Today we're going to have a look at the Cambridge Workshop Potentiometer, circa 1962, and we're going to use it to test a Fluke multimeter, circa 1999, something about then. So I'll just say a few words about the potentiometer first. As I say, in circa 1962, and quick look at the circuit diagram, you can see that we have two batteries, 1.5 voltage, one for potential supply and one for reading the voltage. But basically the whole system is based on the Western standard cell, which you can see there. This has been the case for at least 100 years. Of course, we know that that particular cell generates 1.018638 of a volt pretty well all the time. So we use that to standardise the instruments before we either measure or send out voltages from the instrument to another instruments. Okay, right, just a quick idea. So we have the galvanometer, which is a null galvanometer, so the only reading we're interested in is 0. And you can see the standardisation rheostat there, a standard button and a test button. And they're the two 0 to 100 millivolt switch with the 100 positions. A real workabout that is. And a slide wire, which is 0 to 1 millivolt. So the full range of this is 0 to 1 millivolt. Now originally on the first potentiometer they didn't have a voltage source, but these ones do. So we can provide voltage from the potential source to whatever device we want to. And as you can see, it has two inputs number 1 and number 2. Number 1 is used purely for a thermocouple, which is what you can see now. Now a thermocouple is two dissimilar metals twisted together, one with a hot junction, with a cold junction. Now the hot junction is here and the cold junction is here. Now the idea of this is if you heat one of those junctions, then the hot junction, the difference in temperature will generate a voltage. So to measure the voltage, we need to know the temperature of the hot junction. We don't know the temperature of the hot junction, but we certainly do know the temperature of the cold junction because we have a thermometer, and there it is. And as you can see, it's reading 20 degrees C. So to determine the temperature of the hot junction, we add those two voltages together, and we compare it on the chart, and that gives us a voltage. Usually 1, 2 or 3 millivolts, very small voltages. But in today, we're just not going to do that. We're going to test the voltage output to measure the accuracy of this Fluke multimeter. Okay, so we'll turn on the Fluke multimeter. There we go. It's reading 0, and it's on a range of 0 to 200 millivolts. And we know that the meter here has a range of 0 to 100 millivolts. But the voltage is only applied on output number 2, so this is why the multimeter is connected to output number 2. So, okay, so here we go. So we switch to output number 2, and we dial in 10 millivolts, put 0 on the slide there, and press the test button. And we should have a reading of 10 millivolts, but we don't, we have 9.8, so it could suggest that we have a slight error there. So we'll increase, just say we'll put 30 millivolts or 30.5 millivolts. Press the test button and we're having a reading of 29.9. So you can see there's a slight error on the Fluke instruments. There is other switches on here which we can set. If we switch that to millivolts, we can now, by changing the reading on the millivolt meter, we automatically get the output sent to the Fluke monitor, which again is reading low, 0.5 of a millivolt is reading low. So we'll go to the full range, which is 100 millivolts. We're actually reaching 98.5. So this is an error of 1.5 volts, millivolts. Now I suggest that the Cambridge instrument is more accurate than the Fluke in this case. It may not apply to all ranges. We have another position on this particular switch, millivolt supply. And what this does, you set the voltage here, and then you adjust the output knobs here to give you the correct reading until you get the correct reading. Well, that's it for today. That's the Cambridge Workshop Potentiometer. A fantastic bit of equipment. See you next time.